In this video, we're going to go over how to take a given system of equations and use that to write its equivalent augmented matrix. And there's not really a good way to explain it. So we're just going to kind of jump in. And I think when we jump in, it's going to be easy enough. So if I'm given this system of equations, I need to write an augmented matrix, which means really all I'm doing is taking the coefficients and writing a matrix. So in this first one here, my X coefficients are 3 and 4. My Y coefficients are 4 and -2. For this equal sign, I'm going to put a bar. A lot of times you'll see this, but you won't always see it with a bar here. But if you do see that bar, that is the equal sign. And then we have 7 and 5 right here. And so that is my augmented matrix. Literally just taking the coefficients and writing them together. We don't really need to know this, but this is a 2 by 3 matrix. It always is listed row by column. And I always remember this as RC cola. I don't even know if that's still a thing, but that's how I always remember that it's row by column. And so I have 2 rows by 3 columns here. So same thing here. Now you do need to make sure that it doesn't skip any variables or places. And so you need to put zeros in place of those if you do. So here I've got 3 systems. So I know I'm going to have 3 rows. My X coefficients are 1, 3, 1. My Y is -1, 3, 1. And then my Z is 1. There is no Z here, so we're going to put a 0. So I've got 1, 0, 2. I personally like that bar for my equal sign. Just kind of breaks things up. And then put what's on the other side of your equal sign. We have 10, 5, and 2. And so if we list this row by column, I have 1, 2, 3 rows by 1, 2, 3, 4 columns in this one. So this is a 3 by 4 matrix. Again, you don't really need to know these. That's just kind of extra information. We will need to be able to put these in our calculator. So we will need to know that. But you can also do it by trial and error, really. So example 2 says to write the system of equation that corresponds to the following augmented matrix, then determine the solution to the corresponding system. So in this one, we're going to work backwards. Now I'm given the augmented matrix, and now I need to write it in its system of equations. So equation 1 with this top row here. And so this is always X, Y, Z, unless they tell you otherwise. So I have 1X or just X plus 4Y plus 5Z, and that equals 3. So then move on to equation 2. I have no X's, so I can either put 0X, that doesn't really make sense, so we'll just leave it. We have -3Y, I'm going to stack that under my Y, minus 2Z, and that's going to equal -6. And then equation 3, I have no X's, no Y's, but I have one Z, so it's just Z equals -3. So after we write the system of equation that corresponds with our augmented matrix, then we need to determine the solution of the system. Well, this is really just plugging everything in. I know Z equals -3. So now let's take our second equation and plug that in to get Y. I could plug this into the first one, but then I'm gonna have two unknowns, so it doesn't help me. So I'm gonna go into equation 2. So I've got negative 3y plus 2 times z, which is negative 3. And that equals negative 6. So negative 3y plus 6 equals negative 6. Subtract your 6 over to get negative 12, and then divide by negative 3 to get y is 4. So there's another one. And now let's go to equation 1, so I can get x. So I've got x plus 4 times y, which is 4, plus 5 times z, which is still negative 3, and that equals 3. So we're going to have x plus 16 minus 15 equals 3. So x plus 1 equals 3. Subtract your 1, and we'll get x is 2. So if I want this as a solution, I am going to write this as x, y, z for my final answer. My x is 2, my y is 4, and they told me my z was negative 3. And so this would be my final answer for finding the solution.